In the last lectures of discussion, that is the first lectures of discussion, we have already derived so many important standard integration formula. Today let us recall those formula and remember those formula so that it will be very helpful for us in solving so many problems in integration. So let us discuss one by one. The first formula is integration of the power function x to the power n. We know derivative of x to the power n plus 1 by n plus 1 plus c is equal to x to the power n. So integration of x to the power n with respect to x is x to the power n plus 1 by n plus 1 plus c, where c is the constant of integration. Next, integration of x with respect to x, where x is the linear function or the algebraic function. So integration of x with respect to s is equal to s square by 2 plus c, where c is the constant of integration. In the third formula we have derived integration with respect to x is equal to s plus c. So if we change integration with respect to y, it will give us y plus c. Again, if we change integration with respect to theta, it will give us s plus c. So if we change the variable of integration, so we can find the result accordingly. So changing the variable of integration, suppose we want to integration with respect to t, it will give us t plus c, where c is the constant of integration. So this is the important formula in integrating with respect to x, where this is the differential coefficient. Then we have already derived integration of the trigonometric function, that is integration of a cos x with respect to x is equal to sin x plus c. So we have to remember it. Then integration of a sin s with respect to s is equal to minus cos s plus c, where derivative of minus cos s plus c is equal to sin x. So integration of sin s with respect to s is equal to minus cos s plus c. Then integration of a sec square s with respect to x is equal to tan s plus c, because derivative of a tan s plus c is sec square s. Then we have already derived integration of cos square x with respect to x is equal to minus cot s plus c, because derivative of a minus cot s plus c is cos square x. So in this sense, integration of a cos square x with respect to x is minus cot s plus c. Then integration of a sec x with respect to tan x is equal to sec x plus c, because derivative of a sec x plus c is sec s into tan x. So integration of a sec x into tan x with respect to x is equal to sec s plus c. Then in the ninth formula we have derived integration of a cosec x into cot x is equal to minus cosec x plus c, because derivative of a minus cos x plus c is nothing but cosec x into cot x. So this we have derived integration of 1 by root of 1 minus s square with respect to s is equal to sin inverse plus c or minus cos inverse s plus c, because derivative of a sin inverse s plus c is equal to 1 by root of 1 minus s square. Also derivative of a minus cos inverse s plus k is also the same integrand, that is 1 by root of 1 minus s square. So integration of the formula, that is integration of 1 by root of 1 minus s square is sin inverse s plus c or minus cos inverse s plus k. Then in the 11th formula we have derived integration of 1 by 1 plus s square with respect to s is equal to tan inverse s plus c or minus cot inverse s plus k. Here derivative of tan inverse s plus c is 1 by 1 plus s square. Also derivative of minus cot inverse s plus c is the same function, that is 1 by 1 plus s square. So integration of 1 by 1 plus s square with respect to s, we have got tan inverse s plus c or minus cot inverse s plus k. Then we have derived integration for 1 by x into root of s square minus 1 with respect to x, which is equal to sec inverse s plus c or minus cosec inverse s plus k. So in 13th formula we have derived the integration for the exponential function a to the power x, that is integration of a to the power x with respect to s is equal to a to the power x by ln a plus c, where ln is nothing but log of a. So integration of a to the power x with respect to s, we have to remember that is a to the power x by ln a plus c. Then in the 14th formula we derived integration of the another exponential function e to the power x with respect to which is equal to the same, that is e to the power x plus c. At last we have derived integration for 1 by x with respect to s, which is nothing but ln of mod x plus c or log of mod x plus c, where ln or log are the same thing, where log of s mod plus c is given with the base e. So in the last lecture we have derived this 15th formula. So we have to remember those formulas so that it will be very helpful for us solving the problems in integration. again in the last second and third lectures of discussion, we have already derived the other important formula for integration using the method of substitution. So let us again here recall and remember those formula which will be very helpful for us for solving so many problems in future. So let us also again recall one by one. The first formula is integration of s plus b to the power n with respect to x. Here s plus b to the power n is a component function of algebraic function and a power function. So by method substitution we have got the formula that is integration of s plus b to the power n with respect to x is 1 by a into s plus b to the power n plus 1 by n plus 1 plus c, where c is the constant of integration and the condition that n is not equal to minus 1. If n is equal to minus 1, then the integrand will be undefined. So here therefore n can never be minus 1. Then in the second we have derived integration for sine of s plus b with respect to x. So sine of s plus b is a composite function of trigonometric function and the algebraic function or the linear function. So integration of sine of s plus b with respect to x is equal to minus 1 by a cos of s plus b plus c. Then in the third we have derived integration for cos of s plus b, which is integration of cos of s plus b with respect to x is equal to 1 by a sine of s plus b plus c. Then in 4 we have derived integration for sec square s plus b with respect to s, which is equal to 1 by a tan of s plus b plus c. Then in 5th we have derived integration for cos square s plus b with respect to s, which is minus 1 by a cot of s plus b plus c. Then we have derived integration for sec of s plus b into tan of s plus b with respect to s is equal to 1 by a sec of s plus b plus c. Then we have derived for integration of cosec of s plus b into cot of s plus b with respect to x is equal to minus 1 by a into cosec of s plus b plus c. Then in 8th formula we have derived for integration of the rational function, that is 1 by root of 1 minus s plus b whole square with respect to s is equal to 1 by a sin inverse s plus b plus c or minus 1 by a cos inverse of s plus b plus c. Then we have derived the 9th formula, that is for integration of 1 by 1 plus s plus b square with respect to x is equal to 1 by a tan inverse of s plus b plus c or minus 1 by a cot inverse of s plus b plus c. Then we have derived integration for 1 by s plus b into root of s plus b square minus 1 with respect to s is equal to 1 by a sec inverse of s plus b plus c or minus 1 by a cosec inverse of s plus b plus k. Then in 11th we have derived integration of the exponential function in composite form, that is e to the power s plus b with respect to x is equal to 1 by a into e to the power s plus b plus c. Then we have derived integration for g dash s by gs with respect to x is equal to ln of gs mod plus c or log of gs mod plus c. So among all the formula, this formula in number 12 is most important because this formula contains in the form of a rational form, that is g dash s by gx. Here the numerator contains derivative of the denominator, that is in numerator we have g dash s and denominator we have gx. So this is the rational form. So using this formula we can solve so many problems in integration, which is very much useful for us. So we have to remember it, that is integration for g dash s by gs with respect to s is equal to ln of gs mod plus c or log of gs mod plus c. So this is the most important formula among all these formula. So then in 13th we have derived for integration of the rational function 1 by s plus b, that is integration of 1 by s plus b with respect to x is equal to 1 by a into ln of s plus b plus c. So then we have derived integration for tan x with respect to x. So integration of tan x with respect to x is equal to ln of sec s mod plus c. Then we have derived for integration of cot s with respect to s, which is equal to ln of sin s mod plus c. Then we have we have integration for sec x. So integration of sec x with respect to s is equal to ln of sec s plus tan s mod plus c or ln of tan of pi by 4 plus s by 2 mod plus k. So then in 17th we have derived for integration of cosec s, that is integration for cosec s with respect to s is equal to ln of cosec s minus cot s mod plus c or ln of tan of s by 2 mod plus c. that is integration of a to the power mx with respect to x is equal to 1 by m into a to the power ms by ln plus c. This formula was not derived in the last class, so today we have to derive it. So let us derive this formula by method of substitution. So let us consider the given integrand, that is integration of a to the power mx with respect to x. So here a to the power mx is a composite function of an exponential function and an algebraic function. So we have to substitute for mx, that is v. So put mx is equal to v. So v is a function of x. So we have to differentiate v with respect to x. So it will give us derivative of v with respect to x is equal to m into 1, that is m is the constant and derivative of x with respect to x is equal to 1. So we have m into 1, so we got ma. So now dv by ds is equal to m. So again simplifying, we have dv is equal to m into dx. So replacing dx, we have dx is equal to dv by m. So after substitution and differentiation, we got dx is equal to dv by m. So now let us replace v in place of mx and dx, that is dv by m. So we have from the integrand, that is integration of a to the power v into ds. In place of ds, we have dv by m. So now we got integration of a to the power v with respect to v by m. So again taking 1 by m out, we have 1 by m into a to the power, integration of a to the power v with respect to v. So now by substitution and differentiation, we reach that is integration of a to the power v with respect to v. So this is in formula form. So integration of a to the power v is a to the power v by ln a plus c. So now again simplifying, we have 1 by m into a to the power v by ln a plus 1 by m into c. So again replacing v with mx, we got 1 by m into a to the power mx by ln a plus, so 1 by m into c can be taken as k, which is the constant of integration. So we proved that integration of a to the power ms with respect to x is equal to 1 by m into a to the power ms by ln a plus k, where k is the constant of integration. So in this process, 33 formula, that is 15 formula in the lecture 1 and 18 formula in the lecture 2 and 3. So in total we have 33 formula with us. So using these 33 formula, we can solve so many important problems in integration. So let us start with how to solve problems in integration. Now let us try to integrate the following integrals. So before going to integrate the problems of integration, so we have to carefully observe the integrand. So that is, we have to see that whether the function is in standard form or not for integration. If it is in standard form, then we can directly integrate it. If it is not in standard form, we have to try to transform the given function or integrand into standard form, so that it will be helpful for us in the process of integration. So let us consider the first problem. Let us see how it can be integrated. Now let us try to solve the first problem, that is integration of s square into cos of s square with respect to x. So now carefully observe the integrand. It contains x square and cos of s cube. So this function is not in the standard form for integration. So we are in the past, we are not able to integrate it, but we have to integrate it. How we can integrate it? Let us see. If we take s cube as v, and if we differentiate it, it will give us dv by ds, which is 3s square, where the integral contains the factor x square. So before substituting the function, we have to adjust s square to dx. So adjusting s square to dx, we have integration of cos of s cube and x square dx. So s square cos of s cube dx can be expressed as integration of a cos of s cube with s square dx. Now let us substitute s cube as v, that is v is equal to s cube. So we have v is equal to s cube, where v is a function of x. So differentiating v with respect to x, we have dv by dx is equal to 3s square. So again simplifying, we have dv is equal to 3x square into dx. So as the integrand contains s square dx, so let us find s square dx, which is equal to dv by 3. So now we got s square ds as dv by 3, and we have substituted that ss2 as v. So replacing those, we have cos of s. So in place of cos of ss2 we can write cos of v. In place of s square ds we have to put dv by 3. So now we got integration of cos v with respect to v by 3. Now here the integrand contains with respect to the variable v. So v the variable of integration, so 3 the constant, and it can be taken out of the integral. So before integrating we have 1 by 3 into integration of cos of v with respect to v. Now see, that is the original integrand, which was s square into cos of ss2 with respect to s, was not, we are in that case we are unable to integrate it, but after substitution we got 1 by 3 integration of cos v with respect to v. Now the integrand is easily integrable, and you know that integration of cos v with respect to v is sin s plus c. So integrating we have 1 by 3 into sin of v plus c, where c the constant of integration. Now simplifying we have 1 by 3 into sin of v plus 1 by 3 into c. Again replacing v as ss2 we have 1 by 3 into sin of ss2 plus, in place of 1 by 3 c we can take k, where k the constant of integration. So we got 1 by 3 into sin of ss2 plus k. Now the integration is already over. Now let us solve the second problem, that is integration of e to the power x into sec of e to the power x into tan of e to the power x with respect to s. So now see the integrand, that is the integrand contains exponential function and trigonometric function, where both the trigonometric functions are in composite form that contains the exponential function and trigonometric function. So as it contains sec and tan function, so definitely this function will transform into integration of sec x into tan x with respect to x, but it contains the exponential function e to the power x. So now before integrating or substituting we have to change the function like this, that is integration of sec of e to the power x into tan of e to the power x into e to the power x dx. Now so the original integrand was e to the power x into sec of e to the power x into tan of e to the power x with respect to x. So now adjusting e to the power x with ds, we got integration of sec of e to the power x into tan of e to the power x into e to the power x ds, because we know that derivative of e to the power x is equal to e to the power x. So now in this process of integration we have to substitute e to the power x as v. So substituting we have integration of, let us put e to the power x is equal to v, that is v is equal to, that is v is equal to e to the power x. Now v is a function of x, so differentiating v with respect to x we got derivative of v with respect to x is equal to e to the power x. So again simplifying we have dv is equal to e to the power x into dx. Now see, after substitution and differentiation we have dv is equal to e to the power x ds, that is e to the power x ds is equal to dv. Now replacing e to the power x as v and e to the power ds into ds as dv, in the integral we have integration of sec of v into tan of e to the power x can be tan of v, and in place of e to the power ds we have dv. So we got integration of sec v into tan v with respect to v. So now we reached at the form of standard form. Now the transfer function is easily integrable and we can integrate it, because we know that integration of sec x into tan x with respect to x is equal to sec x plus c. So in using that standard formula we can integrate integration of sec v and tan v with respect to v as sec v plus c, because derivative of sec v plus c is equal to sec v into tan v. So integration of sec v into tan v with respect to s is equal to sec v plus c. So now after integration we can replace v, that is e to the power. So we have sec of e to the power plus c, where c is the constant of integration. So now we are able to integrate the second problem, that is sec of e to the power plus c. Now let us solve the third problem, that is integration of cos square x by 1 plus cot x with respect to x. Now let us observe the integrand, that is the integrand is a rational function in the form of and containing two trigonometric functions, and if we differentiate 1 plus cot x with respect to x, definitely it will give us minus cos square x, where the numerator contains the function that is cos square x. So this integrand is easily integrable by the process of substitution. So we have to substitute 1 plus cot x. So before substitution we have to make an adjustment, that is cos square x will be adjusted with dx. So adjusting dx with cos square x, we have integration of 1 by 1 plus cot x into cos square x dx. So now we have to substitute 1 plus cot x as v, that is let us substitute 1 plus cot x is equal to v. Then we got v is a function of x, so differentiating v with respect to x, we have dv by dx is equal to 0 minus cos square x, because derivative of 1 is 0 and derivative of cot x with respect to x is equal to minus cos square x. So simplifying, we have dv by dx is equal to minus cos square x. So again simplifying, we got minus dv is equal to cos square x into dx. So now after substitution and differentiation, we find that cos square dx is equal to minus dv. Again we have taken 1 plus cot x as v, so replace in the integrand, we can write integration of 1 by, so in place of 1 plus cot x we have v, and in place of cos square dx we have, that is minus dv. So now after substitution we reach that integration of 1 by v and minus dv. So taking minus out of the integral, we have minus of integration of 1 by v with respect to v. So now the original integrand transformed into the another integrand, that is integration of 1 by v with respect to v, which is in standard form. So now we are able to integrate it. So after integrating 1 by v with respect to v, it will give us ln of v mod plus c. So integrating, we have minus of ln of v mod plus c, where c the constant of integration. So now simplifying and replacing v, we have minus of ln of v mod plus of minus c, because we have to multiply minus with ln of v mod, again we have to multiply minus with c. So now finally we can write minus of ln of, in place of v we have 1 plus cot x mod plus k in place of minus c, where k is the constant of integration. So now we are able to integrate the third problem, that is integration of cos square x with cos square x by 1 plus cot x dx is equal to minus of ln of mod of 1 plus cot x plus k, where k is the constant of integration. So the integration is over now. Let us try to solve the following three problems on integration. So now let us consider the first problem, that is integration of sine x by cos qx with respect to x. So now let us carefully observe the integrand, that is sin x by cos qx. It is in rational form, and both the numerator and denominator contains trigonometric functions, and it is not in the formula form or standard form for integration, but we should try to transform into standard form. So let us make an adjustment like this, that is integration of sin x by cos x into cos square x. So breaking cos qx as cos x into cos square x, we got integration of sin x by cos x into cos square x with respect to x. Now again making adjustment, we have, that is integration of sin x by cos x into 1 by cos square x with respect to x. So again simplifying, we have integration of, so sin x by cos x is equal to tan x into 1 by cos square x is equal to sec square x, then integration with respect to x. So we change the original function into another form, that is integration of tan x into sec square x with respect to x. Again this transfer function is not in standard form for integration. So let us again carefully observe it, that is the derivative of tan x is equal to sec square x. So this integrand can be integrated by process of substitution. So we have to substitute tan x as v. So we have to put tan x is equal to v, that is v is equal to tan x, v is equal to tan x. So v is a function of x. So differentiating v with respect to x, we have dv by dx is equal to sec square x. So again simplifying, we have dv is equal to sec square x into dx. So let us see the integrand. The integrand contains sec square x into dx, also tan x. So in place of tan x we can replace v, and in place of sec square dx we can replace dv. So we got integration of v dv. Now see the original integrand which was not in standard form. Now after substitution differentiation transformed into integration of v with respect to v, which is easily integrable, and it is v square by 2 plus c, because integration of x with respect to x is equal to s square by 2 plus c. So in the same way, integration of v with respect to v will be v square by 2 plus c. So now the integration is over, but we have to replace v, that is tan x whole square by 2 plus c, that is half into tan square x plus c, where c the constant of integration. So now we are now we are at the point of integration, that is we have already integrated the function which is half into tan square x plus c. So now let us solve the second problem, that is the second problem for us, integration of cos square ln x by x with respect to x. So now let us see the problem. Here the integrand contains cos square ln x by x, where cos square ln x is a composite function of logarithm function, power function and a trigonometric function. But if you carefully see it, the derivative of ln x is equal to 1 by x, where the integrand contains the function that is 1 by x. So before substitution and integration, we have to adjust 1 by x with dx. So adjusting 1 by x with dx, we can write integration of cos square ln x dx by x. Then let us substitute ln x as v. So we have v is equal to ln x. So v is a function of x. So now let us differentiate v with respect to x. So differentiating v with respect to x, it will give us dv by dx is equal to 1 by x. So now after differentiation, again simplifying, we have dv is equal to dx by x. So after substitution and differentiation, let us substitute those values in the integrand. It will give us integration of cos square. So in place of ln x we can take v. So we have integration of cos square v, and in place of ds by x we can take dv. So now we reach at the integrand, that is integration of cos square v with respect to v. So now after substitution and differentiation, we got integration of cos square v with respect to v. So now this integrand is in formula form or standard form for integration, and its integration is minus cot v plus c, because derivative of minus cot v plus c is equal to cos square v with cos square v. So integration of cos square v dv is minus cot v plus c. So now the integration is over, but we have to replace in place of v, that is minus cot of, so v is equal to ln x. So we got minus cot of ln x plus c, where c the constant of integration. Then let us solve the third integrand, that is, now let us solve the third problem, that is integration of root over 1 minus sine x into cos x with respect to x. So let us see the problem. Here derivative of 1 minus sine x is equal to 0 minus cos x. That means the integrand contains the function that is cos x. So if we substitute 1 minus sine x as v, then the original integrand will transform into standard form and we can integrate it. So let us substitute 1 minus sine x equal to v. So here v is a function of x, then differentiating v with respect to x will give us derivative of 1 is 0 and derivative of sine x is cos x, so we have minus cos x. That is, simplifying we have minus cos x. That is, again simplifying we have minus dv is equal to cos x into dx. So now after differentiation and substitution and differentiation, we find that minus dv is equal to cos x dx, where the integrand contains the function that is cos x dx. So we have integration of a root or of a, so in place of 1 minus sine x we can take v, so we got integration of a root v. So in place of cos x dx we can substitute minus dv. So now again simplifying we have minus of integration of a v to the power half with respect to v. So in the process of integration of a substituting 1 minus sine x as v and differentiation, we reach that the form that is integration of v to the power half with respect to v, where v to the power half is easily integrable by the process of using the integration of s to the power n with respect to x. So using the integration of s to the power n, we have minus of v to the power half plus 1 by half plus 1 plus c, where c the constant of integration. So again simplifying we have minus of v to the power 3 by 2 by 3 by 2 plus of minus c multiplying minus with c. So again simplifying we have minus 2 by 3 into v to the power 3 by 2 plus k in place of minus c. So now replacing v as 1 minus sine x, finally we got minus 2 by 3 into 1 minus sine x to the power 3 by 2 plus k. So hence the integration is now over. Then let us try to solve the following three integrands. Let us consider the first integrand, that is integration of e to the power 2 tan x into sec square x with respect to x. Now let us carefully see the problem. Here the integrand contains exponential function along with the trigonometric functions, and the exponential function is the composite function of exponential and the trigonometric functions. Here in the exponential function we have e to the power 2 tan x, and if we differentiate 2 tan x it will give us sec square x. So this integrand can be easily integrated by the process of substitution. So we have to substitute, that is 2 tan x as v. So substituting 2 tan x as v, we have, let us put 2 tan x is equal to v, that is v is equal to 2 tan x. So here v is a function of x. So differentiating v with respect to x, it will give us dv by dx is equal to 2 into, and derivative of tan x is sec square x. So we got dv by dx is equal to 2 into sec square x. So again simplifying it will give us dv is equal to 2 into sec square x dx, but the integrand contains the factor that is sec square dx. So keeping or solving again for sec square x into dx, it will give us dv by 2. So we got dv by 2 as sec square x into dx, and we have substitute that v as 2 tan x. So replacing v and dv by 2, we have e to the power v, in place of sec square ds we have dv by 2. So now after substitution and differentiation, the original integrand transforms into the integration of e to the power v dv by 2. So here v the variable of integration. So taking 2 out of the integrand, it will give us 1 by 2 into integration of e to the power v with respect to v. Now the changed or transformed function is in the formula form for integration, and it can be integrated. So its integration is half into e to the power v plus c, where c the constant of integration. So again simplifying we can find half into e to the power v plus half into c. So replacing v as 2 tan x, we got half into e to the power 2 tan x plus c, where c the plus k, because in place of 1 by 2 into c we can take k, where k is the constant of integration. So the integration now over. Now let us consider the second problem, that is integration of 1 by x into 1 plus ln square with respect to x. So let us consider the second problem, that is integration of 1 by x into 1 plus square of ln x with respect to x. Now see the problem. Here the integrand is in the rational form, where the denominator contains x and 1 plus square of ln x. Here, if we carefully observe the integrand and if we differentiate ln x, it will give us 1 by x, where the integrand contains the function that is 1 by x. So adjusting with dx as 1 by x, it will give us integration of 1 by 1 plus square of ln x dx by x. So this is the adjustment of x or 1 by x with dx. So now let us substitute ln x as v for easy integration. So substituting ln x as v, we got v is equal to ln of x. Now v is a function of x, so differentiating v with respect to x, it will give us dv by dx is equal to 1 by x, that is derivative of ln x is 1 by x. So again simplifying, it will give us dv is equal to dx by x. So now after substitution and differentiation, we got ds by x equal dv and v as ln x. So replacing in the integral, it will give us 1 by 1 plus v square. In place of ds by x, we can write dv. So now the original function transforms into integration of 1 by 1 plus v square with respect to v, which is in the formula form, that is integration of 1 by 1 plus s square with respect to x is equal to tan inverse s plus c. So this integrand can be integrated by using that formula. So the integration of the function, that is integration of 1 by 1 plus v square with respect to v, will give us, that is tan inverse v plus c, where c the constant of integration. So replacing v, that is ln x, in place of v we have tan inverse of ln x plus c, where c the constant of integration. So now we integrated the function which is tan inverse of ln x plus c, where c the constant of integration. So the integration is over now. Now let us try to solve the third problem, which is very easy one for us, and it can be also integrated by the same method of substitution. So we have the third problem, that is integration of sine to the power 7x into cos x with respect to x. So now the integrand contains sine and cosine function, where the power of sine x is 7 and cos x is only by power 1. So this function or this integrand can be integrated by the process of substitution. So we have to see that derivative of sine x is cos x, but derivative of cos x is minus sine x. But as derivative of sine x is cos x, so here it will be easier for us to substitute sine x as v, so that it can be easily integrated. So substituting sine x as v, we got v is equal to sine x. So v is a function of x, or v is equal to sine of x. So now differentiating v with respect to x, it will give us dv by dx is equal to cos x, because derivative of sine x is cos x. So again simplifying, it will give us dv is equal to cos x into dx. Now see, after substitution and differentiation, we got cos x dx as dv and v as sine x. So substituting in the integrand, we can write integration of v to the power 7, in place of a cos dx we have dv. So now the non-standard integrand transformed into standard form, that is integration of v to the power 7 with respect to v, which is easily integrable, and its integration is v to the power 7 plus 1 by 7 plus 1 plus c, because here we applied the formula, that is integration of x to the power n with respect to x, which is x to the power n plus 1 by n plus 1 plus c. So in this process we find that integration of v to the power 7 with respect to v is v to the power 7 plus 1 by 7 plus 1 plus c. So after simplifying, it will give us 1 by 8 into v to the power 8 plus c. So now finally replacing v as a sin x, we got 1 by 8 into sin x to the power 8 plus c, that is 1 by 8 sin to the power 8x plus c, where c the constant of integration. Hence the integration is over now. Now let us try to solve the following three integrals. So let us consider the solution of the first integral, that is integration of 2 into e to the power tan square x into tan x into sec square x with respect to x. So let us see the problem. Here the integrand contains exponential function along with some trigonometric functions. So the function is not in the formula form for integration, so let us try to transform it into formula form. So let us see how it will be transformed into formula form. So if we carefully observe that, and if we differentiate tan square x, it will give us 2 tan x into sec square x, where the integrand contains 2 tan x into sec square x. So in this process of integration, so we have to think that we have to assume tan square x as v. So let us substitute. So before substitution, let us adjust 2 with it, tan x into sec square x. So adjusting 2, we have integration of e to the power tan square x into 2 into tan x into sec square x with respect to x. So now after adjustment, let us substitute tan square x as v. So let us put tan square x is equal to v. So we have v is equal to tan square x. So here v is a function of x and tan square x is a composite function. So before differentiating, as it is a composite function, it can be differentiated by the process of chain rule. So differentiating v with respect to x, it will give us dv by dx, which is equal to derivative of tan square x with respect to x. So here before differentiation, we have to apply the chain process, that is we can differentiate like this: derivative of square of tan x is differentiable with respect to tan x into derivative of tan x with respect to x. Here we have the function that is tan square x. So tan square x can be differentiable with respect to tan x into derivative of tan x with respect to x. So now we have, in place of tan x, if you take u, so it is derivative of u square with respect to u will give us 2u. So we have 2 tan x into derivative of tan x with respect to x is sec square x. So we got into sec square x. So we got dv by ds is equal to 2 tan x into sec square x. So again simplifying, we have dv is equal to 2 tan x into sec square x into dx. So now after substitution differentiation, we got 2 tan x into sec square ds is equal to dv. Again v is equal to tan sec square. So now replacing v and dv, we got integration of e to the power. So in place of tan square x, we have to put v. So we have integration of e to the power v, and in place of 2 tan x into sec square ds, we have dv. So we got integration of e to the power v with respect to v, which is in easy form, that is integration of e to the power x with respect to x, and it is integrable and we can integrate it. So this integration will be e to the power v plus c, where c the constant of integration. So replacing back v as a tan square x, we have e to the power tan square x plus c. So now the integration is over, and where c the constant of integration. Then let us try to solve the second problem, which is also easy one for us. So let us try to solve the second integral, that is integration of tan inverse x to the power 3 by 1 plus s square with respect to x. So consider the solution for the second problem, that is integration of tan inverse to the power 3 by 1 plus x square with respect to x. So here let us carefully see the integrand. Here the integrand also contains inverse trigonometric function along with 1 plus s square, which is the rational form, and if we carefully see the derivative of tan inverse x is nothing but 1 by 1 plus s square, where the integrand contains the factor that is 1 by 1 plus s square. So this integral can be integrated by substituting tan inverse x as v. So before substitution, let us adjust 1 plus s square with dx. So adjusting 1 plus s square with dx, we have integration of tan inverse x to the power 3 dx by 1 plus x square. So this is the adjustment of 1 by 1 plus s square with dx. Now let us substitute v as tan inverse x. So let us put tan inverse x is equal to v, that is v is a function of x. So differentiating v with respect to x, it will give us dv by dx, which is equal to 1 by 1 plus x square. So now again simplifying, it will give us dv is equal to dx by 1 plus x square. Now see, so after substitution and differentiation, we got dv is equal to ds by 1 plus s square. Again tan inverse is equal to v. So replacing ds by 1 plus s square, also tan inverse x in the integrand, it will give us v to the power 3. In place of ds by 1 plus s square, we have dv. So we got integration of vq with respect to v. Now see, the non-standard function transforms into the standard form, which is in the form of integration of s to the power n. So it can be integrated by the formula, that is integration of s to the power n with respect to s, which is equal to x to the power n plus 1 by n plus 1 plus c. So integrating v to the power 3 with respect to v, it will give us v to the power 3 plus 1 by 3 plus 1 plus c, where c the constant of integration. So simplifying, we have 1 by 4 into v to the power 4 plus c. Again replacing v. So v is tan inverse x. So taking tan inverse x in place of v, we have 1 by 4 tan inverse x to the power 4 plus c, where c the constant of integration. So hence the integration is now over. Now let us try to solve the next problem, that is integration of sec inverse x square by x into s square minus 1 with respect to x. So consider the third problem for integration, that is we have integration of the third problem, that is integration of sec inverse of x square by x into root of x square minus 1 with respect to x. So here the integrand is also in the rational form, where the numerator contains square of sec inverse s, denominator contains the factor that is x into root of s square minus 1. But if we carefully recall the derivative of sec inverse x, which is nothing but 1 by x into root of s square minus 1, the integrands contain the factor. So before substitution, we have to adjust dx with the factor x into root of s square minus 1. So adjusting, we have integration of sec inverse x square into dx by x into root of x square minus 1. So now let us substitute sec inverse x as v. So we have sec inverse x is equal to v. So here v is a function of x. So differentiate v with respect to x, it will give us dv by dx is equal to derivative of sec inverse x with respect to x, which is nothing but 1 by x into root of x square minus 1. So again simplifying, for dv, we have dv is equal to dx by x into root of x square minus 1. So now after substitution and differentiation, we find sec inverse x is v and dv is equal to ds by x root of s square minus 1. So replacing in the original integral, it will give us integration of v square. In place of ds by x root of s square minus 1, it is dv. So we reached at the integral, that is integration of v square with respect to v, which is easily integrable by the process of integrating the function, that is x to the power n with respect to x. So it will give us v to the power 3 by 3 plus c, where c the constant of integration. So again replacing v, that is sec inverse x, we have 1 by 3 into sec inverse x whole to the power 3 plus c, where c the constant of integration. Hence the integration is over now.